All right, so last time we started section 1.3. Okay, we're going to finish up section 1.3 today. Okay, and let's just do kind of a little bit of a review question, okay, about domain and range, and just how we graph something and make sure we can get the right window on the screen. Okay, so first thing I want us to do here is, okay, graph y equals 16x minus x cubed, and then find the domain and range. All right, so let's type that in. So first thing you're going to do is make sure you go, after you turn it on, go to y equals. Type in 16x, and then minus x cubed. Next thing is, I would start with zoom 6. Okay, that's going to give you that standard window from -10 to 10. And if anything's cut off, then we got to kind of adjust it. All right, so it looks like this graph is making kind of like an S shape. It's got two turns in it. Okay, what I'm going to do is just zoom out a little bit. Let's set the y min a little lower. And set the y max a little higher. Okay, that should be high enough that we can see all the turns. Bless you.
God bless.
Okay, that looks better, just barely on the screen, but that works. All right, so there's the find a complete graph. Okay, so on the homework, all you'd have to do is write down what you use for a window. Okay, and specifically, you just need that one, that one, that one, and that one. Your mins and maxes. All right. Okay, next part. Find the domain and range. Okay, so the domain basically is what you are allowed to plug in for x here. Okay, what kind of numbers can I plug in for x?
All real number?
Yeah, I can plug in all real numbers. Okay, the only time you got to be careful with domain is if you're dividing or you're taking a square root. If you're not doing one of those two things, usually you can plug in all real numbers. Okay, ask yourself, is there any number you're not allowed to raise to the third power? No. Is there any number you can't multiply by 16? No. All right, so you can plug in anything you want here. So that's our domain. Just write down all reals. Okay, and range. Okay, range is how high and low it's going to go. Okay? So when you plug in these numbers for x, okay, anything you want, what kind of answers do you get for y? Okay. Anybody see how high and low that graph is going to go? Yeah, someone just said it. Yep. Yeah, it's going to go up forever and down forever. If you just want to zoom out, you can look at it zoomed out a little more. Okay, it does this little twisty thing in the middle, but the left side goes up forever, right side goes down forever. So your range is also all real numbers. Keep in mind, the range might not be all reals all the time. If I did something like this, okay, now my range is not all reals. It does go up forever, but it doesn't go down forever. It kind of has a low point at 0, and it goes up to infinity. Okay, so range can change depending on the function you have. All right, let's try to solve this one, and we'll use the calculator if we can. Okay, it says we're going to make a rectangular pool with dimensions 30 by 50. We're going to put a sidewalk around the pool. And the sidewalk is going to be the same width, okay, all the way around. Okay, they tell us that the area of the sidewalk we're going to build is 600 square feet. Okay, based on that, I want to know how wide is the sidewalk going to be. All right, first thing I would do here is just draw a picture. Okay, even rather than writing all that's good. It's kind of the key facts we need. but a picture is really going to help us. All right. So here's our important things. 30 by 50. Width of x. 600 square feet. Those are the only three things we really need to know. All right, so let me make a picture of a pool. All right, so there's our pool, and that's 30 by 50. 30, 50. Okay, we're going to put a sidewalk around it, and we're going to try to keep the width the same all the way around. Okay, sidewalk has a width of x. All right, so our goal is we're going to figure out a formula for the area of this sidewalk. It's going to involve finding the area of two things and then subtracting them. Okay. What I'm going to do is I'm going to find the area of, let's call this the big rectangle. Okay, find the area of the big rectangle, and then subtract the area of the small. If you do that, you're going to be left with just the sidewalk area. Right, so we'll figure these two things out in a second. Small rectangle, and that's going to give me area of the sidewalk. Any questions on that? That's the big idea of what we're going to do. And some of these we already know. We have numbers. We can just fill in for them. Okay, let's start with the area of the big rectangle. Okay, area of a rectangle. Pat, what's my formula for area of a rectangle?
Length times width.
Yeah, we just need the length and we need the width.
So you're going to do x squared?
So Derek, what's my length of this big rectangle? And keep in mind, it's basically the small one. And then we have that part and that part.
50 plus 2x.
Yeah, this big rectangle on the bottom, it's 50. Plus you have an x plus an x. So the length of it is 50 plus 2x, or 2x plus 50. So there's my length. Now I need my width. How about Dalton, same idea. What's my width going to be?
30 plus 2x.
Yeah, it's going to be 30 plus the x on the top plus the x on the bottom. So 2x plus 30. Minus the area of the small rectangle. Okay, that's the pool. That's in there, that's my pool. So I just got to do 30 times 50, and that'll just be a number.
180.
How much?
180. Oh, yeah, I think more.
180.
I mean, 50.
15?
150.
100, no, 1,500, yeah. All right, so area of the small rectangle. And what did they say the area of the sidewalk has to be?
600.
Yeah, they told me it's 600. Right, so now I'll just do this out. Okay, I'll distribute it and see what I get. Okay, we'll solve for x. Okay, we can use the calculator if we need to. So we're going to get 2x times 2x is 4x squared. 2x times 30, that's 60x. 2x times 50, that's 100x. And now watch what's going to happen here. 50 times 30 is 1,500 minus 1,500. What happens? It's gone. So 50 times 30, don't even worry about that part. It's going to cancel. I got some like terms, and I'm going to combine those together. It's 160x. And generally, when we have an equation that has an exponent of 2, it's called a quadratic. We want to get everything on one side. So, Upi, how could I get this 600 on the other side to solve it? Yeah, just going to bring it to the other side as negative 600. All right. Now, if we wanted all these numbers are divisible by the same number. We could do that just to make everything a little smaller. Paige, do you see what 4, 160, and 600 can all be divided by? Yeah. Thank you, Pages. All right, so divide everything by 4. Of course, 0 divided by 4 is just going to stay the same. Okay, 160 divided by 4 gives me 40, minus 150. Okay, now there's a couple ways you can solve it. Okay, quadratic equations can be solved with factoring. Can be solved with, well, how else can you solve a quadratic equation?
By
Something you learned with the three letters in it, A, B, and C. Everybody remember the name of that? Starts out negative B. Plus or minus? Yeah, that whole thing. What? Yeah, what's the name of that thing? Quadratic formula. Okay, so we could use quadratic formula. We could use factoring, or we could just graph it. Okay, for this one, let's just graph it. Right, so we got x squared plus 40x minus 150. We're going to have a lesson on quadratic equations later where we practice using that formula, so we'll do that at another time. Okay, so we're going to graph this. Bless you. And we want to see where this graph is going to hit 0. Okay? And remember, it's a U shape, so it could hit it twice. So I just typed it in. I'm going to start with zoom 6. We'll see how that graph looks. Okay, now is that a complete graph? Can I see it? No, I can't see everything I really should be seeing, but I don't need to. All I'm looking for is where the graph crosses 0. Okay, it's a U shape, so it probably comes like way down and comes back up in the negative part somewhere. But I don't even need to find that. Because if we're looking in the negative part, would that make sense? Negative value for the width of the sidewalk? No. Right? So here's our positive value right here. So just go second calc, and you're trying to find where this equation hits 0. Okay? So the option you'd use is second calc 0. Okay, the way you do it, just got to find your cursor. Okay, it looks like it's around 3.5. So once I get to 3.5, my cursor should come on the screen. X. Yep, there it is. So make sure you pick a point that's somewhere to the left. Okay, puts in that dotted line. Pick a point somewhere to the right. Puts in another dotted line. And then take a guess. Okay, the guess isn't overly important here, but it tells me that the width of the sidewalk, it's about 3.445 feet. All right, but you really want to make sure you get that equation equal to 0 first. Okay. If you don't want to divide everything by 4, you don't have to. If you graph what we have up above, you're going to get the exact same answer. Okay, the calculator can handle bigger numbers, no problem. Okay, any question on that? So I'm going to give you guys one similar to that in the homework. Just keep this idea in mind. That's your general idea. So next thing that they look at in this section, it comes up in a few sections, is what's called projectile motion. Okay? What I'm going to do is give you guys a formula. In physics, you might have to prove it or find it. Okay, and here I just give it to you. And what this formula gives you is the height of an object. Okay, think about throwing a baseball from an outfield, right? Kind of might make a path like that. You get that kind of arc. This formula will tell you how high the object will be after a certain amount of time it leaves your hand. And it depends on two things. It depends on how fast you throw it, and it depends on how high off the ground it is when you release it. All right, so if you were standing on top of a building and released it, it's going to go a lot farther before it hits the ground than if you were standing on the ground and threw it. Okay, so v sub 0, that's how you pronounce that. That's your initial speed. S sub 0, that's your initial height.
So 16t or 1?
That's negative 16t. Yep, negative 16t squared plus v sub 0t plus s sub 0.
So is that v for initial velocity? That's like a v and like a really small o?
Yep, v sub 0. That's their symbol for
Alright, so just start.
starting velocity. It's like, yeah, and starting height.
The same, yeah.
Yep, s sub 0. That's going to be a number when we do it. V sub 0 will be a number, and we'll usually fill in a value for time. Okay, so in this problem, it says we're going to shoot a rocket. Okay, in this case, it's going to be shot straight up from ground level at an initial speed of 64 feet per second. Now, if we're shooting something up and it's starting on the ground, how high is it when it starts? 0. Okay, if you do something from ground level, there's no initial height. It's on the ground to start. Versus if I did it on this table, it would be like 3 feet off the ground. Okay, but this one's on the ground. All right, so first thing I want to find is what time will the rocket be 50 feet above the ground? Right, so the first thing I'm going to do is just set up my equation, but I'm going to fill in the numbers I have. 64 for v sub 0 and 0 for s sub 0. Okay, we're not even going to need initial height in this problem. It's from the ground. All right, so our height equals negative 16t squared plus v sub 0t. What's my initial speed in this problem?
64.
Yep, 64. And normally I'd put plus initial height, but there's no initial height here. Okay, so that's it. That's your equation. This is our height off the ground. Okay, we want to know when this object is going to be how high? 50. So I'm just going to fill 50 in. And this is almost exactly like the last problem. It's another quadratic equation. When we're solving a quadratic, what number do you want to get by itself on one side?
0.
Yep. So we're going to move that 50 to the other side. So negative 16t squared plus 64t minus, you know what, I'm trying to decide how I want to do this. Oh, there's two ways we can do it. We can either put 0 on one side, or you know what, let's make it even easier. Let's just graph it.
Is that a -5?
Let's just graph it the way it is right there. Since we're not using algebra to solve it, we don't really need to get 0 on one side. We're just going to use the calculator to draw a picture. So why do more work than we have to? What I'll do is I'll put this in y1, and I'll put this in y2. Okay, and I think doing it this way is going to give you guys a better picture. Okay, so what we're going to do, we're going to put a line right at 50, and then we're going to draw this parabola. Okay, negative 16. Remember, you got to use x as your letter. All right, now we're trying to find out when this object hits 50 feet. So I would set my screen at least that high, and the ball might even go higher. So why don't we set our height at 90? okay, for y max. Okay, negative values for the height don't make sense. The ball's not going underground, so you don't need to see below 0. X is your time. Negative time doesn't make sense either. Okay, 0 is the lowest time we could have. Now, x max is how long the ball's in the air. We don't know. Let's try 10 seconds, and then if it cuts it off on the screen, we'll make it bigger. Okay, so there's 50. Actually, I think that's pretty good. Okay, so that red line kind of models the path of the ball. And that blue line is where it's at 50. So basically, we want to know when the ball is in that range. Did anyone remember from last week how you could find that point right there?
Isn't it that x intercept and y intercept?
These aren't intercepts, but the word is similar. Yeah, so what we're looking for here, it sounds very similar to intercept, but it's...
You would go to second calc.
Yep, intercept. Okay, and what we're going to do is basically find each intersect. Okay, I'll do the one on the right. If somebody else can do the one on the left, that'll just save us a second. Pick a point on the first curve, the second curve, and now the guess does matter. Wherever I do my guess, it's going to give me that one, okay, whichever one I'm closer to. All right, so up until 2.94 seconds. Okay, after that time, the ball's going to drop back below 50 feet. All right, so time. Does it say above and equal or just above? I guess it could equal. It says when is it 50 feet above the ground, so that would be 50 feet or higher. Yeah. And what's our time value on this side? When does it hit it?
How do we figure that out?
Second calc intersect.
I don't know if we're exactly on it, because I think I'm close, but I don't know which one it would be yet.
So if you do second calc intersect, it'll tell it to you exactly. So pick a point on each curve.
I would pick the point.
And then you just hit enter. Yeah, it'll say first curve, second curve, and then the last thing it'll say is guess.
Then you hit enter on the guess.
Yep, and you hit enter on the guess. So anyone get about 1.06? 1.06?
Okay.
All right. So after you throw the object, at about a little over a second after it leaves your hand, it's going to be up at 50 feet, and it'll stay up there till just about 3 seconds, and then it's going to fall back below 50 feet. Yes?
How do you write 2.9?
We just did second calc intersect on the right, just like we did on the left. Yep. Okay. And then actually the last thing, this one's pretty easy. Keep your graph right in there. Okay. When do we hit the maximum height, and what is the maximum height? Well, if you just look at your graph, there's an option for calculating the maximum. Second calc maximum. Okay, and to do that, see how I'm on the blue line? I don't want to be on the blue one. I want to be up on the red one. So I just hit up. Pick a point where you think you're to the left of the maximum. Pick a point to the right. So now you're telling the calculator, I want you to look between these two dotted lines. And then the guess, just be as close as you can. All right, so we're gonna round this off. Yeah, 2. It's 1.999999998 on my calculator. You might have gotten 2.0000001. Okay, it depends. So what is the maximum height I hit here?
64.
Yeah, I hit 64 feet, and at what time do I hit it?
2 seconds.
At 2 seconds. All right, so at 2 seconds, the max height of 64 feet is reached. 2 seconds, you reach your maximum height of 64 feet. Okay. Any questions on that one? All right. And then last thing that'll finish up 1.3, it's called a piecewise defined function. Okay, basically, the idea with this kind of function, all you're doing is drawing 2 graphs on the screen at the same time. That's it. You're drawing 2 pictures on the screen kind of at the same time. Show you an example. Okay, I'm going to show you exactly how you type that in on the calculator. Okay, this is what you call a piecewise defined function. Okay, what you usually see is this kind of curved bracket, and then you see a couple formulas. Okay, and what we're doing is we're saying, well, you're going to use one of these formulas some of the time, and you're going to use a different formula the rest of the time. Okay? How do you know when to use which one? That's what these conditions are right here. All right, so when we sketch this on the calculator, if x is less than 1, we're going to use this first formula to draw the picture. Any other time, we're going to use the second formula. Right, so it's going to look like 2 different pictures on the screen. Half the picture is going to be the top graph. The other half of the picture, it's going to be the bottom graph. Okay, and you've got to type this in a little differently than you're used to. Okay, not a lot different, just a little bit. Okay, does everybody have what a piecewise function is? Okay, the kind of piecewise functions I'm going to give you, I'm only going to split them into 2 parts. But I could split it into 3 parts. I could say you have 3 of them. Right, but let's try typing that in. Okay. The only thing that's different here is you've got to put it in parentheses, okay, when you type it in. Okay, so if we got anything else in there, just get rid of that. Okay, I'm going to put parentheses, 3 minus x squared. And then I'm going to put another parenthesis. And in these parentheses, I'm going to put the condition. Okay, I want to do that one as long as x is less than 1. So press x. And then to get your less than, okay, press second. And then press math. Okay, that'll give you all your inequality symbols. X less than 1. That's it. That's the only thing that's different. Okay, now type in the bottom one. Parenthesis again. If you forget the parentheses, it will mess up. X cubed minus 4x. Close your parenthesis. And now next to it, put when you want to graph that one. Okay, I only want to graph that one if x second math greater than or equal to 1. And we'll do zoom 6. Okay, we'll just do a standard window. Any question on typing that in? Yep.
I can do after negative 4x.
You can't do a negative?
Yeah.
Just press minus.
Yes, ma'am.
Yep. Make sure for negative, don't use the one below the 3. That's only for a negative number, but we're doing subtraction here.
How did you get to the symbols?
The symbols?
Yeah.
Press second, math.
Second.
Yep. And I'm going to do zoom 6. Okay, so notice it started sketching a parabola and then it stopped because we said we're going to stop at 1. And then at 1, all of a sudden we're going to switch to this other one. Okay? So what we get is two pictures on the screen. They're not connected in this case. Ignore these horizontal lines on the x-axis. Those shouldn't be there. All right, so what it really should look like, you've got part of a parabola, and then it kind of picks up like that. Okay, but that's what it should look like.
Mine are connected.
Yeah, if you've got an older calculator, what it'll do, in fact, I can probably make mine connected kind of like yours. Does yours look like that? Yeah. It shouldn't be connected, but the calculator has trouble drawing things that are not connected. At least older ones do. So the older ones try to connect everything, right? But it should not be connected here. Yeah. Cameron?
On mine, it just made lines. It didn't draw anything. It drew like a straight blue line that broke up here and there, and then a straight red line that broke up here and there.
All right, and you typed in,
I typed in.
you got it typed in exactly with all the parentheses and everything?
Yeah. Is there like a key between the x is
No.
greater than or equal to 1 or anything like that?
No, no spaces. And then zoom 6 is what I did.
Yeah, and mine just made straight lines or something.
All right, let me take a look at that after. Keep that in there. I'll look at that after. Could be the calculator too. We might just have to reset it. Anytime you need to reset your calculator, you can just go to second memory, 7 will reset it, and the first option, 1, will reset everything. I'm not going to do it on mine, but you could do that. Okay, so let's call a piecewise function. Just a graph that's in 2 pieces, and that's it. Okay. So I just want to make sure you know how to graph them on the calculator. All right, and last thing we'll do is kind of a quick review of like y equals mx plus b, slope, points, okay, that kind of stuff. Okay, so there's your slope-intercept form of a line. Okay, if you already know this, you don't need to write it down again, but if you think you need it, go ahead. Anyone tell me what the m stands for?
Slope.
Slope, and the b?
Y.
Y-intercept. Okay, so anything we draw that's y in the form y equals mx plus b, that's going to look like a line. Okay, that's called a linear function. Okay, so linear functions are written just like that, meaning when you draw that, it looks like a line. It's not curved like some of these other graphs we've been doing. Okay, m and b can be any real numbers you want. That's what this says. M and b are elements of the real numbers. So your slope can be a fraction, can be a positive, can be a decimal, can be a negative. The only thing your slope can't be is 0. If your slope is 0, basically you'd get this. Y equals a number. That's just a horizontal line. That's called a constant function, not a linear function. Okay, we actually graphed a constant function earlier today. We graphed y equals 50. We wanted to know when the ball would be above 50 feet. So we just put a constant line at 50. All right, and basically what we can do is we can come up with an equation of a line, and we can use it to kind of model a situation. Right? So for this one, just watch me do the equation. Don't copy it all down because it's in your book. I just want you to see how I make an equation basically using slope. Okay? So copy down what I'm about to write, but don't worry about the whole problem because this would already be on a test written for you. Does everybody have what's on the left? Good with that? Okay, I'm going to use the idea of slope. Right? So to use the idea of slope, I kind of want to think of what I have here as a coordinate. Okay, I got some money values, okay, which I just put some boxes around. And I got some time values. And then this here. Right, so we're going to try to think of those as coordinates. Let's start out with year 0. Okay. When I first purchased the house, before any time went by, how much was the house worth? Yeah. When I first purchased the house, it was worth $60,000. Okay. Now, 10 years later, what's the value of the house? Yeah, $85,000. And what we're going to do is assume that the value of the house, basically it starts here, it ends here. The value of the house has just gone up, just to make it simple. Right? So I tried to think of my data in terms of a coordinate. Okay, first thing I'm going to do is I'm going to find the slope. And to find the slope, I put that formula on the other page. It's y2 minus y1 over x2 minus x1. Okay, if it helps, let's label these. So x1, x2, y1, y2. All right, so I'm going to find my slope. It says to take 85,000 minus 60,000. Divided by 10 minus 0. Okay, so on the bottom I get just 10. And what's 85,000 minus 60,000? 25 what?
25,000.
Yep, 25,000. Can divide by 10. So I get a slope of 2,500. Okay, that's my m in that equation. Now I need my b. Well, the b is the y-intercept. Okay, when x is 0, what's y? 60,000. There's your y-intercept. That's where it crosses the y-axis. When x is 0, go up 60,000, put a dot. That's going to be your point on the y-axis. In which letter is that again? 60,000? So this is my slope. That's m. 60,000 is my b. All right. So here's my equation. So the value of that house is equal to 2,500x plus 60,000. Now, if you wanted to know what's the value of the house after 37 years, just fill 37 in for x. Let me tell you the value of the house. All right. Yeah, I think that's all I'm going to do with that problem. Okay, so any question on that? Yeah?
Is the y-intercept always the y1?
It's all, if x is 0, then yes. If it's not 0, then no. I picked it to be 0 this time because I wanted a simple one. Yep, if you got a 0 here, then that would always be your y-intercept. Now, you could use this formula two ways. I could say, what would be the value of the house in 20 years? And you'd fill 20 in for x. Or I could say, when was the house worth $71,250? Where would you fill that in? You could fill that in for y and figure out what year the house was worth that much. So you'd either fill in for x or for y. You could use that formula. All right, so we got slope. There's two special cases, horizontal and vertical. Anybody know what the slope of a horizontal line is?
Y.
We're going to talk about how you write the equation in a second. But just how steep is it? How would you describe a horizontal line?
0.
It's 0. Okay, it's not increasing, it's not decreasing, it's perfectly flat, it's 0. And how about a vertical line? It's as steep as you can possibly have. How do you?
Anything other than 0.
It's what?
Anything other than 0.
Well, there's one word we use. It's actually a word we use to describe it.
Undefined.
Undefined. Okay, undefined. Okay, so these are your two special cases for slope. Horizontal lines, slope of 0. Vertical lines are undefined. And because these have special slopes, somebody started saying, well, the equation is going to be a little different. Okay, it's not y equals mx plus b. It's a little simpler. If you have to graph a horizontal line, it looks just like this. Y equals a number, like y equals 2. If you have to graph a vertical line, it's x equals a number. We can't graph vertical lines on the calculator. Okay, we can't do it. You can only graph horizontal lines and then lines in y equals mx plus b. Right, so I want to find the equation of a horizontal line that would go right through the point 2, 3. Right, so Kyle, what would horizontal line starts out with which letter?
3.
That's good, that's the number, but which letter, y or x?
Oh, why?
Y.
Sorry.
And you already said it, y equals 3. Yep. If you draw that horizontal line, it would go right through that point. And Jamie, how about a vertical line that would go through that point? Yeah. Okay, if you could draw that line, x equals 2, it would go right through the point 2, 3. That's it. Okay, so it's so much easier than y equals mx plus b. Sometimes people, they get tripped up with it. Okay, but that's all it is. Okay, let's say I had an equation written like this. 2x plus 3y equals 6. How could I change it so that y is by itself? What's one? Just give me one thing I'd have to do, Amanda.
You would have to move 6 onto the other side of the equation and move y onto the other side.
I would probably keep the 6 where it is, but
Just subtract 2x.
yeah, I would move the 2x to the other side. So at least we have the y on one side and the x on the other. And how should I write this to try to keep it in mx plus b form? Yeah, Jamie?
Negative 2x plus 6.
Good, I like how he said that. He said negative 2x plus 6 rather than 6 minus 2x. Okay, and then my last step would be to divide everything by 3. So my equation is y equals negative 2/3 x plus 2. What's the advantage to doing that? What becomes a lot easier now if I asked you to do something with this? Yep, Adriana? Yeah, you can find the slope real quick, you can find the y-intercept real quick, and you can draw it. It's not that you can't draw it this way. It's just most people are used to slope-intercept form. Okay, so that's how you rewrite it. Just get y by itself. One other form that sometimes we use is point slope. Okay, it's helpful if I give you a point and I give you a slope, and I say find the equation that would go through the point that I gave you with the slope that I gave you. And it says y minus y1 equals m times x minus x1. And this is what you fill in for when you use it. The y1, the m, and the x1. So I'll give you a point, and I'll give you a slope. Just like that. Slope is a half. Point, negative 2, 3. All right, so let's start with negative 2. Well, Fernando, is this x1 or y1?
X1.
Yep. And 3?
Y1.
Y1. Just fill it in and see what we get. we've got y minus y1. So far, so good. Equals m, which is a half, times x. Now be careful here. It's x minus x1.
Wouldn't it be positive 2?
Yeah, why is it going to become plus 2?
There's 2 minus.
Yeah, it's x minus minus 2. Okay, so it becomes plus 2. And that's it. You could leave the equation just like that. If they wanted it in y equals mx plus b form, what I would do is distribute the 1/2 and then add 3. You could put it in y equals mx plus b. Okay, but if they don't ask for that, we don't need to. You can leave it just like that.
What if you did it?
What if I did it? Yeah, it would be like this. Y equals 1/2 x. 1/2 times 2 would be plus 1. And then do a plus 3. It would look just like this. If I distributed it and then added 3. Yep. But again, you don't have to do that on this problem. Okay, parallel lines. Okay, we'll go over that real quick. For 2 lines to be parallel, what has to happen? Same slope and one other thing.
Why?
Different y-intercept. What if they were the same slope, same intercept? Then they're the same line. Okay. So 2 lines are parallel if they have same slope, different y-intercept. Perpendicular, that one's a little tricky. Some people get mixed up on this one. There's a connection between the slopes, but it's not the same. The slopes actually have to be 2 things. Yeah?
Don't they have to be like a reciprocal?
That's part of it, yes. They do have to be reciprocals and one other thing. Opposite, yeah. So one's positive, one's negative, and they're reciprocals of each other. All right, so if you had a problem, okay, like this, it says write an equation of a line that's parallel to that and passes through that point. Well, if you're going to find an equation that's parallel to this, what's the very first thing you have to know about what I just circled?
Yeah, it's actually y equals m.
Yeah, why would you want to write that in y equals mx plus
So
b?
it's easy to solve.
Yeah, it's easier to find the slope. If you're going to find an equation parallel to this, you've got to know the slope of this. Okay? And whatever the slope of this is, the slope of my other line is the same because they're parallel. So the first thing I would do, write it in y equals mx plus b. Bring the 3x to the other side as a negative, and divide by -2. Okay, what I did when I divided -3 by -2, negative divided by negative is positive, and then +1 divided by -2, that's a negative. So Cameron, what's my slope here? And if I'm going to draw something parallel to that, it's also going to have a slope of 3/2. Okay, so there's my slope. Do I have a point it has to pass through? What is it? Well, so my slope is 3/2. Forget about that -1/2. We don't need it. What else do I need? Yeah.
It has to pass through 1 negative.
It has to pass through 1 -2. All right, so there's my point. Now this problem is just like the one we did right here. There's your slope, there's your point. There's your slope, there's your point. Just fill it in. Okay, I'm going to do y minus y1 equals m times x minus x1. Okay, this one I'm not going to rewrite, but you could distribute and minus the 2. Okay, any questions on that? All right, so a lot of this is probably review you've probably done before. I just want to make sure everybody's kind of familiar with it though. And this will be our last thing. Okay, a linear inequality, basically that's when we draw something and we shade above or below a line. Okay, I tried to make a very little simple chart so you know when to do what. Okay, to graph a linear inequality, okay, we're going to start by graphing just like it was a line. Okay, just like if you were going to graph y equals 2x plus 3. Okay, we're going to do this the same way. The only difference is we have two choices for what kind of line we can draw, solid and dashed. If you've got a less than or equal to or a greater than or equal to, that's a solid line. If you've got a less than or a greater than, we use a dashed line. And once we draw in that line, solid or dashed, you've got two choices, shade below or shade above. Well, if you see these less than symbols, less than is below, greater than is above. Right, let's finish up with that one. For me, when I have to graph something, first thing I like to do is get it y by itself. So what I'm going to do is minus the 2x. Okay, bring that to the other side. And then the last thing I would do is divide everything by 3. All right, a little messy to graph it, but we'll just do the best we can. Okay, first thing I'm going to do, graph your y-intercept. Okay, if you're not sure where 4/3 is, it's at 1.3 repeating. So go 0, then go up to about 1.3. Okay, from that point, how do I use my slope to get another point? Which direction do I go? Remember, Eric? Remember how to do that?
No, sorry.
How we use that point? No?
Don't you have to draw 3 up and then -2?
Okay, what's the top number in your slope? What's another name for that? Begins with an R.
Your eyes.
Yeah, that's your rise. And the bottom number? Your run. Right? So this is saying a rise of -2, which means what?
Goes down to.
Down 2. And then +3 to the
Right.
to the right. So we're going to go down 2 and right 3. So down 2, right 3. If you want to do it again, go down 2, right 3. Okay, in this case, my symbol is a less than. Okay, is that a solid line or a dashed line?
Dash.
Yep, dashed line. Okay, so just put that in. And it's a less than. Less than means I'm going to shade which way? Below. Okay. And that's it. Okay, so a little review on slope, inequalities. Okay, and your homework tonight will be on 2 pages. Part of it will be 1.3, part of it will be 1.4. Okay, so page 31, that's the part on 1.3. And then page 42, that's the part on what we did on 1.4. Right, so we'll take a look at that tomorrow. And don't forget, we'll do our take-home test on Wednesday night. That'll be due Thursday morning. Okay, but we'll talk more about that later in the week.